All right, so I just want to run through the circle. Now, the basic equation of the circle is x squared plus y squared equals r squared. Just to give you an idea of the reason why that is the equation, if you're looking at, like, you've got any point here, and you've got the point P, which is xy, and it's moving so that it's always equal, it's always the same distance from this point at 0 there. So it doesn't matter where it goes, it's always going to be that same point that's 0. And if you fix that on there, and that was your y value there, and so that's your y, and that's your x, and that's your r, because that's always, that point there is always r. And you use Pythagoras, then x squared plus y squared will equal r squared. Wherever that point moves, that's the condition that it lies under. So the centre of this circle would be 0, 0, and the radius is r. And wherever, when you draw it, it sits on here, so that's r, that's minus r, and minus r. So when you're writing the domain and the range of this circle, the domain would go from, and it can equal it, so it's got to be like a boxed thing on your interval, so minus r to r, and the range would also be from minus r to r. And if you look at that, I'm just going to highlight it so you can see. So see, the y values range from r down to minus r, and the x values range from minus r up to r. And that's your domain and range. Now, if you shift this circle and you move it around, then if you put in like x minus h squared, and h is any value, and y minus k squared equals r squared, then basically that's an r too, the other one's a k. Basically the centre here would be hk, and the radius would be r. So it's like an internal shift, because if you look at these things are inside here, so you've got minus h and minus k. So that's why the sign's opposite, that's why it becomes h and k. So like an example, if I had, say I had x minus 2 squared plus y minus 1 squared equals 4, then that means that your centre would be 2, 1. So the x value shifts to the right 2, and it goes up 1 for the y value. And the radius is, now that 4 there, that is r squared. So it is the square root of 4, because you just want r, so that would be 2. So if I was sketching that circle, I go 2 to the right, and I go up 1. And I have to draw that with a radius of 2. So that means that's my centre point. A radius of 2 would bring me 2 that way, out to 4 that way, down to minus 1 that way, and up to 3 that way. So my circle, not a wonderful circle, but it would look something like that. Okay, now have a think about the domain and range of that, because you can do it. You can do any domain and range, you just got to get it from the graph. So if you're looking at the domain, you're going from 0 up to 4. And if you're looking at the range, you're going from minus 1, the y value, up to 3. So let's just write that down. So the domain would be from 0 up to 4, and the range would be from minus 1 up to 3. Now, they actually need to be boxed intervals. They'll be boxed intervals because they can equal those values at those endpoints. So just one more. Let's just look at x squared plus y plus 2 squared equals 9. Okay, so if you're looking at that curve, notice how there is nothing in here now. So that means that x value must be 0. So that would be 0. And the y value here would be minus 2. So that's your centre, 0 minus 2. And then the radius is the square root of 9, and the square root of 9 is 3. So if we were looking at drawing this circle, we would go to 0 minus 2, which is here, and we have a radius of 3. So if that's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, it's a pretty big circle to draw, especially if I'm going to draw it like a nice one, but it will look like something like that.